We can't avoid discussing global warming and its impacts on El Nino. So we'll do it with two papers. There are two ways to think about it. What can be already seen, maybe in the evolution of El Nino through the season, We talked about onset of the discharge, evolution of ENSO, growth phase, mature phase, decay phase, and so on. And then there is a broader question of whether the duration, intensity, frequency, or patterns of El Nino are changing because of global warming. And there's plenty of discussion on all sides, and the answer is not very clear. Okay. Again, it comes down to having a small number of samples. Global warming is happening, let's say, for 100 years. Then how many El Ninos do you have during this time? Maybe 25 to 30. Is that enough to distinguish between pre-global warming El Ninos and during global warming El Ninos? People use Holocene data, paleoclimate to argue this, that, and the other thing, but there's hardly any agreement, especially because models do produce some responses, but it can go in very different directions based on the model. So I'll start with this paper, which came out in 2012. It talked about whether a global warming signature was already emerging in the tropical Pacific. We'll look at a figure and it becomes obvious in a minute. But we'll read the abstract as usual. The tropical Pacific experienced a hitherto unseen, the DOI is given here at the bottom, by the way. The tropical Pacific experienced a hitherto unseen anomalous basin-wide warming from May 2009 through April 2010, with the maximum warming to the east of the dateline, but for a weak anomalous cooling west of 140 degree east after the early boreal fall. Okay, continuing, our observed analysis and model experiments isolate the potential teleconnections from the tropical Pacific during the summer of 2009. Further, we show that Further, we show through an empirical orthogonal function analysis of the tropical Pacific SSTA that the anomalous conditions in the tropical Pacific during this period could have manifested as a canonical El Nino, but for a slowly intensifying background east-west gradient. So look at another paper for 2023 El Nino, which argued that it was mostly driven by ocean dynamics because the coupled wind patterns were not there, or not very clear. This zonal SST gradient is subject to an increasing trend associated with global warming. A possible implication is that any further increase in global warming may result in more basin-wide warm events in place of canonical El Ninos, along with the occurrence of more intense La Niñas and El Nino Modokis. The first author here is from the Modoki gang. People call it Central Pacific El Nino, Dateline El Nino. The Japanese associated authors here, Ashok K, tend to call it Modoki, which has some meaning in Japanese, which is very poetically explained by the people who coined this term. But the simple story is here. If you look at the June, July, August, September sea surface temperature anomaly, 2009 was mild El Nino. You can see that unlike the canonical El Nino pattern where you have a cold tongue and coastal warming extending towards the dateline, but you have this horseshoe pattern of cold SST anomalies, which is what captured by the El Nino evolution in the Rasmussen Carpenter paper of 1982, for example. So this pattern is obviously very different here. We'll look at the warming trend in a minute, and you'll see that West Pacific is a hotspot for ocean warming under increasing greenhouse gases. So the idea was to look at EOF1 and EOF3 and argue that EOF3 is the global warming pattern, and when you superpose 1 and 3, you manage to reconstruct the observed summer SST pattern during the evolution of El Nino, and we'll see that 2003 and 2026 also look like this in the summer months. So is that a fundamental shift in the way El Nino is evolving? What implications does it have? What happens to the Bjerknes feedback in this case? Because remember, Bjerknes feedback depends on the sea surface temperature gradient, sea level pressure gradient, associated wind response, divergence, lifting of the thermocline during La Nina, and the sinking and the further warming and further weakening of the winds, etc., during an El Nino, right? So we looked at that already. So if you look at the warming trends for 1994 to 2024, you can look at another period, but you obviously see some standard events like the polar amplification, the warming hole in the North Atlantic, extreme warming over the European and West Asian regions, and the cooling here that is very opposite to what's happening on this side, which is warming and Indian Ocean warms. So remember, these are trends, degree Fahrenheit per decade. So it's not a anomaly pattern, it's a warming trend pattern. And if you warm less or cool here and warm here, you are increasing the SST gradient and pressure gradient, and presumably you can sustain this pattern. There are details like this is related to the ocean dynamic thermostat, but essentially if you bring up cold water here, the ocean is going to soak up the heat, which means this is able to modulate global warming by putting heat away into the ocean. And then the question is, what is the impact of this pattern, which is now happening, let's say, more and more. So here is the SST anomaly for parts of, all of it's going from May into June. So you can see that again, this prominent cooling is not so visible. As we evolve into July and August, this is likely to remain or even get warmer here in the anomalies because of the superposition of the global warming pattern on the El Nino pattern, and Indian Ocean is doing its thing, and we are expecting an IOD to evolve and so on. So the key question is, if global warming is already becoming part of the El Nino evolution, how is the El Nino evolution itself changing? Is it really producing more warmings around the dateline? Well, 2015-16 was this way, 2026 is also this way, so it's definitely not a CP El Nino, it's the canonical or cold tongue El Nino. And if you look at the January to May 2023, you again see that it was warming already along the coast, was still colder than normal here around the dateline, but West Pacific was obviously warm. You can see this as the opposite phase of the Pacific Meridional mode, which is a warm sea surface temperature anomaly that extends into the western central Pacific. But if you look at the later months, June 2023, you can see that clearly this is now warm all the way. So this is more like the 2009 pattern as well. And 2026, did I show? Yeah, that's 2026. So you can clearly see that the last few El Ninos are beginning to show this Western Pacific warm pattern instead of the classical cold pattern associated with the warm pattern here. So you can be confident enough for now, keeping in mind the limited number of samples, that maybe West Pacific warming due to increased greenhouse gases is beginning to affect the El Nino pattern, especially during the evolution. We'll see how it evolves in the coming months to the mature phase. So we are not necessarily talking about the mature phase, we are talking about the evolution, because evolution determines how strong it will get, what the teleconnections will be, and so on. And if the Indian monsoon is any indication, then it's a deadly combination of global warming and El Nino, and maybe the different evolution of El Nino, because there are some arguments that the CP El Ninos or Central Pacific El Ninos warming around the dateline, in fact, bring bigger deficits in monsoon rainfall, but that also was based on older analysis from 2006 or so. So if we don't have enough samples of both types of El Niños, then obviously it's hard to argue whether CP El Niños are having different effect on anything like the Indian monsoon or the North American teleconnections and so on. So there are plenty of papers arguing in every direction, but some indications are there that the West Pacific warming is beginning to manifest itself on the evolution of El Nino. Okay, we'll come back and look at one more specific paper on how global warming can be expected to affect the El Nino itself, and that's always about whether there will be more frequent El Ninos, stronger El Ninos, weaker El Ninos, fewer El Ninos. This is like the cyclone argument. Total number of cyclones are not necessarily increasing. The argument is that the stronger category cyclones are increasing, and that's not uniformly true because you have typhoon region, North Indian Ocean, North Atlantic hurricane region, and so on. So all these are tricky issues, but we still cannot ignore them. Okay, so we'll keep trying to say more as we go along if there are new findings that come up. Okay, see you in the next podcast again on global warming and El Nino.